Hey, this is Mr. Aiden. This is the 2022 AP Calculus AB free response question number 3. This is the first of the non-calculator free response questions. This comes from the May 9th exam. And check out my YouTube channel, Mr. Aiden. Check out my website, mraiden.com. Check out my gear and my swag, Mr. Aiden. Just joking. Just check out my YouTube channel. Check out my website. And let's get to question number 3. Question number 3. Students could see it right away. It was one of these fundamental theorem of calculus type problems where they give you a graph and they're having you try to find the areas underneath, maybe some slopes, some derivatives, things like that. And you can see right away, what I wanted my students to see is f of 4 is equal to 3. 4 is your frame of reference. So, and they gave us a graph of f prime. But what do we know is when the x is equal to 4, we are at a position of 3. That's our frame of reference. And so my students, right away, they would think of finding the areas underneath this. Now, if this is my frame of reference, anything behind it, anything going to the left-hand side is going to be opposite. So since this semicircle is underneath the curve, that will actually be a positive displacement there. Anything this way, because it's above the x-axis, that's going to be positive values. So we have to think of the frame of reference. So the first thing they wanted us to find is f of 0, f of 0. And so how do we find f of 0? Well, we're starting at a position of 3, and we're going to take the integral, or the area, and we're going to start at 4, okay? And we're going to go backwards to 0. Of f of prime of x dx. We're going to take the area. So what is a semicircle's area? A circle's area is pi r squared, and the radius, of course, is 2 all around. So pi r squared is 4 pi, but it's a semicircle, so it's 2 pi. 2 pi. Now, you might say, yo, Aiden, this is below the x-axis. That's going to be negative 2 pi. Well, remember, our frame of reference is right here, which means this will be positive 2 pi. We're going in the opposite direction. So we're going to have 3 plus 2 pi, which is 3 plus 2 pi. And that is what f of 0 is. That's the position at f of 0. If you think of it the other way, if you think of this as your frame of reference, and let's say we're at a position of 3 plus 2 pi, and now we're going forward, and we go negative 2 pi. That negative 2 pi cancels out with that positive 2 pi, and we're at a position of 3. Hopefully that made sense. The second thing we want to find is f of 5 is equal to 3 plus the integral from 4 to 5, the area under the curve from 4 to 5. So what is the area under the curve right here from 4 to 5? Well, let's look. Base of 1, height of 1, half that. And that's 0.5, so 3 plus 0.5 equals 3.5. Now, keep in mind, on these type of A problems, we might actually use these later on in this number 3 problem. So just keep that in mind. We know what the positions are at each of these 2 points. Okay. The next thing they want to do is they want to find the points of inflection of the graph. Find the x-coordinates of the points of inflection. And so right away, I think of points of inflection, and I think of the second derivative test. And the points of inflection is when we're looking at when the second derivative of a function, okay, of f here is equal to 0, okay, when the f prime prime of x is equal to 0. And we are specifically looking at, those are possible points of inflection, but we're looking at where does the f prime prime of x go from positive to negative or negative to positive. And that's where we have a point of inflection. And so we got to think about it. If we're looking at the f prime prime, we're going to be looking at the f prime graph, this graph right here, his slopes. Okay, so we're looking at where the slopes are equal to 0 or where it is undefined, where those slopes are not defined. And there's 2 points where the slopes are not defined. right here at x is equal to 4, that's a candidate, or right here at x is equal to 6, that's a candidate. Well, we have to think about it. Are the slopes changing? Well, let's see. Before 4, the slopes are all positive. The f prime is greater than 0. Okay, sorry, f prime prime is greater than 0. The slopes of these lines you can see are in positive. Over here, the f prime prime of x is greater than 0. Over on the other side of 6, the f prime prime of x is less than 0, which means that this x coordinate of x is equal to 6 is a point of inflection according to the second derivative test. And that is a full justification of your answer. You're showing, you're explaining all of it as you go along. Okay? Let's go on to C. C says, let g be defined as the function, so I know g of x is equal to f of x minus x. And we're looking for what intervals is g decreasing. So what intervals is g decreasing? Well, how do I find out if a function is increasing or decreasing? I go to the first derivative test, which means g prime, sorry, not g prime prime, g prime of x, we're looking at where is g prime of x less than 0. That is where it is decreasing. That is where it will be decreasing. And so that is a nice part of my analysis. Now I have to take the derivative. G prime of x equals f prime of x minus 1. Okay? And I'm seeing when is this less than 0? When is it less than 0? Okay? And so remember, this is a graph of f prime. So when is f prime minus 1 less than 0? Well, I know when f prime of x is equal to, minus 1 is equal to 0 is at right here at x is equal to 5. At x is equal to 5. Okay? Which means, and also right over here, but you can see above, between 5 and 7, between the intervals 5 and 7, this is not going to be true. We know f prime of x minus 1 is less than 0 for all the intervals, from 0 all the way to 5, but not including 5. So all the way to 5. You could also write that from 0 is less than x, which is less than 5 right there. And so you could call those the intervals, and you can see take any one of these values, okay? Take right here at x is equal to negative 2. Negative 2 minus 1 is negative 3. That's less than 0. That is where g is decreasing according to the first derivative test. And that's my analysis. Let's finish out this problem. This problem number 3. This says we want to find the absolute minimum value, okay, for the function defined in g. The function g defined in part C. Okay, so I'm going to come back to this function, g of x equals f of x minus. So g of x equals f of x minus x. Okay, and we're looking for the absolute minimum value. So I'm going to look at the first derivative test again. And I also have to use my endpoints as candidates. Okay, so I am going to use my endpoints as candidates. So how do we do the first derivative test? That's when g prime of x is equal to 0 or it's undefined. And those are possible critical values and possible minimums and maximums, but we also have to use our endpoints, okay? Usually you get a point for even considering the endpoints. So g prime of x is equal to f prime of x minus 1, okay? And I'm going to set that equal to 0. So I'm asking myself, when does f prime of x, I'm going to do some algebra, equal 1? Well, we equal 1 right here, and we also have to use the endpoint, okay? So we could have x is equal to 0, we could have x is equal to 5, and we could have x is equal to 7. 7 includes one of my endpoints, which is nice, okay? So when I take a look at this, I'm going to plug this in. I'm going to see is the g prime of x positive or negative between these values. So if I take a look at the g prime of x between 0 and 5, g prime of x is going to be less than 0. It's going to be a negative value. Plug in any one of these points. Plug in at 4. F prime of 4 is 0. 0 minus 1 is negative 1. I'm going to be a negative value right here. Between 5 and 7, I plug in any one of these points, and I know g prime of x is greater than 0. It's going to be a positive value here. Okay, so let's think about it. How do we know the absolute minimum value? The absolute minimum value, you can see my function is decreasing, decreasing, g is decreasing, 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 and then after x is equal to 5, it's increasing, 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 which means at x is equal to 5, that's the x coordinate where we have an absolute minimum value. It's a relative minimum value. It's also the absolute minimum value. It's the lowest we can get, which means we're going to come back because they wanted to find the absolute minimum value, not just the x coordinate. So we want to find g of 5. G of 5 is f of 5 minus 5. Okay, how do we find out what f of 5 is? Remember, let's come back to a. We know f of 5 is 3.5. So we're going to use that in there. 3.5 minus 5 equals negative 1.5, and that is the absolute minimum value of g defined in Part C. And that is a full justification of the answer. Hope this helped. This was the 2022, the new AP Calculus AB free response question number 3. I'll catch you on some other problems. Keep watching Mr. Ayton videos.